What time is it? Well, by BBC time, it is 12:06, and it's 12 seconds on, 12 seconds, 16, 17, on the YouTube video. We need to watch this roll over to 7 to get an exact reference on atomic time. Now, BBC's broadcast is 2 seconds delayed over exact atomic time that I get on my radio-controlled watch. And time comes from BIPM.org. That's the French Institute of Weights and Measures, where they receive all the signals from the atomic clocks in the world, average them, and send them back. And the time, there it is, at 56 seconds, we turned over to 7. So that's atomic time. They record the vibration of a loose electron in the cesium-133 atom, and it has a certain number of vibrations, which equals the SI unit a second, which is roughly 6.121 billion vibrations. And, you know, many people don't know much about atomic time because they don't have an interest in it. But I do, so I read a book on splitting the second and the origin of time. So apparently Apple in their iPhone, they put in software in the phone that allows you to look at a map and see where this phone, wherever it was, which is kind of interesting because if you were a wife that heard about this before the news heard about it, and your husband left his phone around, if you suspected he was cheating on you, you could go to the phone, download it, the software, look where the phone is, and if you get enough data and you can zoom in, you can know that this phone was exactly on the street. He'd have a lot of explaining to do if he had no good reason to be on that street. Or for that matter, you can just look at someone's call record. But if a man is punting and seeing other women, say mistresses or prostitutes, he's not going to be leaving that record on his phone of his call record, or he'll have a second phone, or he'll just use phone boxes. It depends on how careful you want to be for whatever level of cheating you're doing, be it over a few years, over a lifetime. And this research shows that most people cheat and are not monogamous because, for example, they say that 1 in 10 babies born is not born to the marriageal dad. Basically, the woman becomes promiscuous in her 7th year of marriage and sleeps with not an alpha male, just more often it'll be an alpha male she'll go for, and she'll have a kid by a different man. So in the family of 4 or 5 kids, 1 or 2 could be fathered by somebody else, which makes perfect biological sense in terms of evolutionary biology and the survival of genes. For example, most dominant men that are powerful with a strong draw, attractive, are more likely to be promiscuous. I think that's what the research shows. In terms of rats in the lab and what happens in the natural world, well, it's no surprise that men and women behave this way. I think in the primate world, it's only the gibbon that's monogamous, and one other primate. So of the... how many primate species are there? Maybe like 39 to 50. I wish I could name all the species, but I can't. But that's... in terms of primology, and what I read recently, that is the only species of primates that is monogamous of the 50 or so. Wow! And that's been studied. So these patterns are based on, obviously, genetics, be it epigenetics, the methylation of histones, or other ways to block or enhance gene activity. Whatever the structural inheritance of this evolutionary behavioral pattern is, it still exists, although we haven't mapped it yet, and that would explain for the diversity of behavior among mammal species that can actually be quantified to get some data from this. But it depends on how closely you want to look at the data, like in terms of knowing the finite space of all units in the group. Like, you can't know the binary. If behavior was yes or no, and it could be mapped as binary, you can't know the binary footprint of every one of those pieces of the data in the research group, because you got to sample that group. So then it all becomes a bit blurry in terms of how we can say that this behavior or this pattern exists. But then you got to know probability and the equations of probability theory and statistics to visualize that into whatever shape it is, because all math is based on patterns and shapes. If it can be modeled as a manifold or a phase space or a Higgins field with field vectors in some Euclidean space, like, it's hard to visualize those words into pictures which an AI could pattern recognize, to then think around that to the algebraic geometry that it relates to, or the differential equations, or whatever branch of mathematics it is. Like, it could be topology and understanding crossing numbers of knots. Like, this is just stuff that I made up. We take a 3-flip Mobius strip, we cut it down the middle, we can turn it into frame knots, which just kind of stand up like a ribbon where it crosses over or under. But if you change that frame knot into just a standard knot, you can see that from the Mobius strip you get 3 different knots, one with loops, one with a non-alternating figure of 8 knot, one with a trefoil knot, and you reduce that by Whitney tricks to get the unknot in those 2 knots that are either trefoil knots or non-alternating figure of 8 knots. We pull it through itself as if it's invisible. We can't make sharp bends. We pull this back through right here to get this part, and then this just overlaps over this way to get the unknot. You couldn't pull it apart this way because you'd make 2 pinches, and that would cancel the theorem of the Whitney tricks. But this one's really nice. This one is just like a coiled one, and it doesn't make the unknot. You get 4 loops, but the 4 loops there represent the 2 twists. The 4 loops here represent the 8 twists that are left in the manifold that you get when you cut this down the middle. But those 4 loops represent the 8 twists. However, with a normal 1-flip Mobius strip, the number of twists that results in the loop afterwards is 2n plus 2. So when you got 1-flip Mobius strip, when you cut it down the middle, 2n is 2 plus 1 is 3. So the Mobius strip has 3. The Mobius strip with 1 flip, when you cut it down the middle, has 4 flips left in it. 4 twists left in the loop. Just I'm gibbering on about. Sorry. The little, but it just goes to show in terms of you got to see it to think it. And here's one more manifold. I took this example. I switched the trefoil knot there to the other crossing. So instead of being under there, it's over there. And then when I put this knot into a frame knot and put the edges back together, I thought I would make a new manifold. Well, I did make a new manifold, but to get from this manifold to this manifold, which is a 3-flip Mobius strip, you got to uncross the 3 crosses of the trefoil knot in the frame knot before you put it back together. I don't know. You can see there's 2 different sides of that kind of. It's like 3 propellers put together tip to tip with the 1 twist in each little bar. Oh, so I was just talking about getting a timestamp now. Oh yeah, by atomic time at 12, 15, and 10 seconds at 9, 7 seconds on the clock. So we'll just check now before we hang up the time delay between Radio 1. By atomic time, it's 12, 15, and 30 seconds, and 26 on the YouTube video. I just wanted to see the delay between Radio 1's time. So when I call out the time, I'll go 57, 58, 59, 0, and we'll see when Radio 1 rolls over. And we have just enough time to do that before the video finishes. We got 15 seconds by YouTube to keep it under 10 minutes, and 8 seconds here. 53, 54, 55, 56, 57, 58, 59, 0. 2 seconds. So there's an exactly 2 second delay. That's it.